Hello everyone, today we have a discussion about diodes, one of the main elements in the electrical circuits. So diode is one of the semiconductors, and the duty for diode is to make one directional or one way current in any circuits. And the shape of the diodes is like these images that you can see. They are different diodes, and normally the diodes are classified based on the rating of the voltage and the current that can work with them. So this is symbol for the diode, and normally diode can be installed in the circuit in a series, and it can also work in both AC and DC circuit. It's not matter. So assume that we have a voltage source like this, and it's make one sinusoidal voltage waveform, as you can see, like this. When we have a diode, this diode just remove the negative part, so it can just let the positive current go through the diode. So you can see the positive current will go and the negative current is just zero, something like this. And the application of diode is for changing, for example, AC sinusoidal waveform to DC waveform, for example. And this is diode. We have cathode and anode, and we have two polarities, positive and negative, something like this. And if we have positive polarity go through this side, it will go, and if we have negative current, it cannot go. For example, here, if you have a voltmeter, if you connect through the diode, here you can see that the diode is the impedance or resistance is, for example, 0 to this side, and to this side the resistance is from 0, and from that side is infinity, for example. As I said, diode easily can just remove the negative part, and if we have, for example, these DC voltage like this, DC voltage also can go to this one completely, but if this go to negative, it cannot go. We have a concept as a RMS or root mean squared in any circuits, and these RMS values say that, okay, if we have a DC system, for example, this 240, this is RMS or maximum and minimum value is exactly the same, but for AC system, it's really hard to say, okay, how much is the current, because it's changing over time. We have a concept as RMS, and RMS say that, okay, in average, our AC voltage or our AC current will make how much temperature or energy, and that one is equal to which DC voltage. For example, in your home, you say that, okay, we have 220 volts AC, but that 220 volt is RMS value, is not maximum or minimum value. If you want to find the RMS value, we have this equation. This equation is say that, okay, just divide the peak value to a square root of 2 to find the RMS value. So we have the rectifiers, and the rectifiers is made in by diode. And if you have an AC voltage source, you want to make a DC output, you should make a rectifier by using diodes. What's the application? For example, television, laptop, phone, or anything, all of them working by DC, but the plug that you have in your home operated by AC. So you cannot connect them directly, so you need some rectifiers. And the rectifier cannot change the RMS value so much, so the RMS value should be same value. So here we have half wave rectifier, and the rectifier is just one diode. So if you have this input, then if you just use the diode, output will be like this, and is not so much good because we have a lot of oscillations, and the RMS value is 31% of the maximum value. Here is one example that we had. So if we want to find the voltage drop, if we have 100 ohm resistor, assume that this is DC, and we have 240 volt RMS value as a AC. If we want to find how much is the DC output, the DC voltage DC is equal to 45% of the V RMS, then it will be 108, for example. Then, as you could see, we had a lot of voltage oscillation. It go to maximum minimum. So we should somehow solve that issue. Then we have a half-wave rectifier with one smoothing capacitor. So we install one capacitor here. That capacitor makes some smoothing reaction. So when the voltage go up, this is charge. When going down, it's going to discharge. So we have this green waveform. So we can see it's more something like a DC one. So for DC, this is the ideal one, just one direct line. If we don't have that smoothing capacitor, this is AC one, just remove this one, it will be something like this. So it's not good. But now with the smoothing one, you can see we have some more or less constant, but it's not perfectly constant, but it's more or less constant. If we want to make it much better, we can put full wave. We can make full wave rectifier circuit. We can put one DC diode here, another diode here, and how it's working when we have the positive polarity, it go from here. When we have negative polarity, it go from here. So that resistor feel something like this. But again, we have a lot of oscillations. Then another way is to make a full wave bridge rectifier. We can make diode like this. And when we have a positive polarity, it go something like this, go through this and back from here. When we have a negative polarity, it go from here. Then if we have this full bridge plus a smoothing capacitor, it will be something like this, more or less constant DC. So this is the best operation for making AC input to the DC output. So you can see it's more or less constant value. Here we have one example for the diodes. When we have here we have positive polarity, then we have a current go through here to the negative polarity, and here the current go through this one. And here we have an example if you want to find the output, because the direction is from here, then we can just remove that diode. As you know, the diodes cannot be controlled, so it's not controllable, and it's working only by positive and negative. We have thyristor, and the thyristor has a gate. It's exactly something like diode, but from this gate you can connect to switch, and by 0 and 1 you can make it open and close. Then you will have some control. For example, here this is thyristor, is more or less same to diode, and if you have a thyristor you can make a pulse, something like this, and this. When this is 1, for example, is open. When this is 0, is closed. So easily you can change how much it should be opened and how much it can be closed by using the thyristor.